All right, guys, welcome to 1.5. And 1.5, we're looking at a bunch of quadratics. All right, so a couple of things that I want to make you aware of first. At the top here, it says u squared equals d. If u squared equals d, then u is equals the plus or minus square root of d. Right, and that just means if you square something in a problem, nothing happens. But if you take the square root instead of a problem, like you introduce to get rid of a square or something like that, then you have to account for both the positive and negative versions of that number. For instance, -3 all squared is 9 and 3 squared is 9. So you have to account for when you take the square root in the middle of the problem, you have to account for both the positive and negative versions of the square root. And that shows up a lot here in quadratics. The other part about quadratics is it's written in the form a uh, ax squared plus bx plus c. It's written in that form. Okay. Now your quadratic formula is that x equals uh, opposite b plus or minus square root b squared minus 4ac all over 2a. Now the b squared minus 4ac, that's also what we call the discriminant. And whether because it's under the square root, if it's positive, it tells us one thing. If it's zero, it tells us another thing. And if it's less than zero, otherwise known as negative, it also tells us something. Like so, in 1.5, we're solving all these things for x, and a lot of times we get more than one x. But we're trying to figure out what are the solutions of x. And by definition, the solutions of x is that if you were to plot these equations on a graph where it crosses the x-axis, if it crosses the x-axis, that's the solutions of x. So let me give you a quick rundown of what you're talking about. So here is a graph where you have a parabola, and it's obviously going to touch the x in two different spots. Here is a graph where it's actually going to touch it in one spot right here. And then here's a graph where it's up here, it doesn't actually touch the x. And that's what we're talking about. So if the discriminant is greater than zero, then it's going to be two unequal real solutions, which is what we're talking about here. This is your scenario one. Uh, and then if it's zero, that means it's sitting on the x-axis and I only have one solution. And because it's sitting on, it's technically repeated. Okay. And then if it's less than zero, that means there's no real solutions, which means I'm going to have imaginary numbers. This is not a lesson about imaginary numbers, but imaginary numbers, they are there. They do exist. They're what we call the complex numbers. Um, but they get their name because real numbers had their name first. And if something's not real, what is it? It must be imaginary. So it's really kind of not the best naming convention that we've seen. And students tend to struggle with, like, well, if they're imaginary, why do we have to learn them? Well, it's better if you think of them as complex numbers because they do exist and they are very important. The point is, if the discriminant is less than zero, it means you have a negative under the square root, which means you are not going to have a parabola that crosses the x-axis. So that's what we're talking about here. All right, and if you notice, there are several different ways that we can work with quadratics. And so I've got each of these labeled, and we're going to get into it. All right, so for um, number one, I'm going to this is a quadratic equation, and we're just going to factor this. So that's going to be x squared breaks down to x and x. My second sign is positive or is negative, so I'm going to have one of each sign. And then my factors are 35 or 1 and 35, 5 and 7. Because my signs are different, I ask myself what times what is 35 and subtracts to give me 2. And because the signs are different, the bigger factor, in this case 7, because it's going to be 5 and 7, 7 is going to get the sign of the middle term, which is negative. So it's going to be plus 5 minus 7. Now, you set each of these equal to 0 and solve for x, and you're going to find that x equals -5, positive 7. -5, positive 7. Okay? And that's all there is to it. So that's one way of finding out how to solve a quadratic equation. So on number two, we need to get everything to the same side first. All right. So I'm going to multiply this out. That's going to be 3x squared minus 6x equals 11x. Well, let me just go ahead and move this. I'll subtract. It's going to be minus 11x squared plus 9x equals 0. And then I'll use the next step to clean this up. That's going to be 3x squared minus 11x squared. That's going to be -8x squared. Negative 6x plus 9x. It's going to be positive 3x equals 0. Okay. Because I only have the two terms, I don't have the third term, but both terms do have an x, I can take it out. So you essentially treat it like a GCF, a greatest common factor. All right. And because that first term is negative, I'm going to go ahead and take out a negative x. And then that's going to leave me with 8x. And because I took out the negative, I'm going to get a sign change. -3 equals 0. Okay, now, while ago on number one, we said each factor equals 0. Now, I don't have two parentheses on number two, but I still have two factors. The first factor is -x. And so I'm going to say -x equals 0. I'm going to say 8x minus 3 equals 0. I'm going to solve for both. Well, all you have to do on the first one is to either multiply or divide by -1, and that moves the negative to the other side, but anything times 0 is 0, and 0 is not positive or negative, so it's just 0. And I'm going to move the 3 to the other side by adding 8x equals positive 3, and then when I divide, x equals 3/8. Okay, so there's that. I have 2 answers on 2 as well. Okay, on number 3, you're going to do this thing called the square root property, which means I'm going to isolate the x squared, and I'm going to move it. So let's start. I'm going to move everything away from it. So let's start there. 3x squared equals, I'm going to add the 9 to the other side, -117 plus 9. So that's the same. It's the same thing as saying 117 minus 9, and then making your answer negative, and that's going to give you 108 and make it negative. You divide by 3, you get x squared. X squared equals -36. Now, you typically can't take the square root of a negative number. However, this is where the imaginary numbers come in, because I is the square root of -1. So if you take the square root of -36, you can separate that into -1 and 36. Well, the square root of 36 is 6, and the square root of I, the square root of -1 is I. So, um, so let's see, remember, I have to take the plus or minus of this. It's going to be -36 underneath, but I can rewrite this as x equals plus or minus square root of -1 times 36. And again, I can take the square root of both of those, because the square root of the square root of -1 is I. So this is going to be plus or minus 6i. As far as imaginary numbers go, that's pretty much all you need to know, is that the square root um, of -1 is I. That's how we represent it. Okay, and that is really helpful when it comes to quadratics. Now, completed square. I feel like completed square gets a bad rap, but it's actually kind of fun if you think about it. Let me work the problem, and then I'll explain to you why we call it complete the square. Okay, so what I want to do is I got x squared minus 2x. That's my original. I want to find a third term that allows us to factor nicely. And I want to do that by taking that middle term, -2, and dividing by 2, which will give me -1. And then I'm going to square that. And so when I do that, I get um, x squared minus 2x plus 1. So again, I took half of the middle term. So -2 divided by 1, or sorry, a -2 divided by 2. That gives me -1, which I'm then going to square, and that gives me +1. And that's what I put here. Okay. So now x squared minus 2x is something that will factor. And not only will it factor, but it will factor rather nicely. You get x and x. The second sign is positive, so both sides are the same as the first. So you get negative, negative, and then the factors of 1 are 1 and 1. And so you get x minus 1 twice, which means I can rewrite this as x minus 1 all squared. And I say squared because this is the square that we're trying to complete, right? Whether there is a third term there or not, you can always use this process called completing the square to get this term, this parentheses, to show up, which is super helpful as you continue to learn how to graph and do all that other stuff. So it's really helpful. And I actually really like the completing the square method, although it gets a bad rap. Now, the quadratic formula, the quadratic formula is what we're going to use next. Okay, and remember, I wrote that up here, right? Opposite b plus or minus square root b squared minus 4ac all over 2a. Okay, and my a is in front. A is in front. This is b, and sign included, and this is c. Okay, so that's going to mean opposite b is -4, plus or minus square root b squared, so it's going to be -4 all squared, plus um, sorry, b squared minus 4ac minus 4. A is 1, c is 40, all over 2 times 1. Okay, so let me scoot this over, give some room to work, because factoring works sometimes, complete square works sometimes, quadratic formula works every time. Okay, so let's clean this up. The opposite b, that's going to turn into a +4, plus or minus square root. B squared is 16. 4 times 40 is 160. This is going to be -144, because it's 16 minus 160 all over 2. Okay, well, similarly to number 3 here, 144 is the square root of 144 is 12, and the square root of -1 is I. So this is going to be 4 plus or minus 12i over 2. And because all of my terms are even, I can factor out a 2, and that's going to be 2 plus or minus 6i. Okay. Now, Number six, a lot of times I just want to know what the graph is doing. Is it opening up? Is it crossing X? Is it sitting on X? Is it going to touch X at all? And I can use the discriminant for that. Remember, the discriminant is just the inside of the square root. Okay, so b squared, that's going to be -7 squared minus 4 times 1 times -2. Usually when you in either A or C, but not both, if either A or C is negative, that means that middle sign is going to be a positive, which means I'm going to have a positive number, an outcome. I'm not going to get a negative under the square root. So let's see, that's 49. That's going to be plus 8. And so that is 57. So what does that mean? Well, if we scroll back up to the top of the page, we have a situation where it's greater than 0, which means I'm going to have two unequal real solutions. In other words, it's going to hit the x-axis twice. And so that's what that means. Now, everybody's favorite, word problems. Right? The area of a rectangular wall of a barn is 65 square feet. So remember, if you have a rectangle, the area is simply length times width, or base times height. Okay, it says the area is 65 square feet. And it says the length is 8 feet longer than the width. Well, because the length is based off the width, let's let W be X. And then length will be X plus 8. Okay. And again, you find area by doing X length times width. So I'm going to say X times X plus 8 equals my area, which is 65. Now I'm going to multiply all this out, get everything to the same side, and figure out what my length and width are. So this is going to be X squared plus 8X minus 65. Okay, before I really get into this 1 and 65, I know 5 and 13 are my factors. There could be more, I don't know off the top of my head, but I know this is going to be enough for us. So I got X, X, X. My second sign is negative, so I'm going to have one of each sign. Okay, and then the bigger of the two factors is going to get the sign of the middle term. So this is going to be plus 13 minus 5 equals 0. And I had to keep going one step further, and X plus 13 equals 0, X minus 5 equals 0. Okay, and then that's going to give me X equals -13 and positive 5. Well, there are certain dimensions that can't be negative, and that would be like length, width, height, time can't be negative, distance can't be negative. All right, so I can't use this. However, so I'm going to plug in, so X is 5, which means length is going to be 13 feet and feet. Anytime you're working with one of these application problems, you want to make sure that you include your units. So we want to know what we're talking about. All right, guys, that's 1.5. Hope you enjoyed it. Hope you got something out of it. Rewatch as much as you need to. If you have questions, reach out, and I'll see you in the next video.